All right, welcome. This is the Math 8 Unit A review packet. This is going to be covering part 5, 6, 7, and 8. Okay, so this is the second part. Okay, but this is covering part 5, 6, 7, and 8. Okay, this is for the Math 8 review. This is basically week 5. Again, this is for chapter 2. Okay, transformations. All right, so here in part 5, it says the line segment AB, here's the line segment AB, is translated 2 units left and 1 unit up to form this new line called CD. So they're asking all the coordinate points here. Okay, so first of all, let's actually just do it. Okay, so if we draw the arrow, that is 2 units left, right? 1, 2, so that's 2 to the left, okay, and 1 up. Okay, and we label the new points. C, A becomes C. Do you see how A becomes C? And B becomes D. Okay, and these are your two new points. Make sure you connect it because it's a line segment. You're translating this line 2 units left, 1 unit up. So the question is this: what is the coordinate of A? This is again, every single point follows the format of parentheses x comma y. So in this case, what is A? This is 0 in the x, 1 in the y, so that is A. What is B? 3 in the x, right here, 3 in the x, and 3 in the x, 3 in the x, and 3 in the y. So it's B is 3, 3. What about C? Looks like it's negative 2 in the x, 2 in the y. What about D? 1 in the x, 4 in the y. There you go. So now the question is this: what is the length of AB and what is the length of CD? Here, you can almost count it. Let me show you. So here, a lot of students try to count this, right? So notice how this is like 1, 2, 3, but it's slanted, right? There's a technical there. If you want to know the exact distance, you would have to use the distance formula. But for the sake of this, I'm just going to estimate, okay? So I'm going to say it's a little under 4, right? Because here's 3, but it's not really 5. So it's a little bit under 4. It's around 3.7. Okay, so we would say this is 3.7. Because this is 3.7, CD, which is its translation, is also going to be 3.7. Okay, so is this line segment AB congruent to line CD? We would say yes, they are the same length because during a translation, the length does not change values, right? It is the same length before and it's the same length after. The size of the object remains the same during a translation. This is very important, okay? The size of the object remains the same during a translation. Next one, 2. Here, same image, but this time we go 4 units right and 2 units down to form this new line called EF. Okay, so A becomes E and B becomes F. All right. So what is the? Let's do the transformation. I think it went 4 units right. So 1, 2, 3, 4, and 3 units down. 1, 2, 3. Yep, that's how you got E. 1, 2, 3, 4. 1, 2, 3. That's how you got F. So what is the point for A? Again, that is the same thing as before. Again, every single point is in the format of parentheses x comma y, close the parentheses. So here, this is 0 in the x, 1 in the y for A. It is 3 in the x, 3 for the y for B. It is 4 comma negative 2 for the E. And it is 7x and 0y. So it is F is 7 comma 0. Again, what is the length of AB? I think we figured that out from before. It is around 3.7. Okay, we translate it, so it's still 3.7. We would say that they are the same length because during a translation, the object does not change value. The size of the object remains the same during a translation. So the size of the object remains the same during a translation. It's 3.7 from before, and it is 3.7 afterwards. Okay, good. Let's do the next one, part 6. Okay, part 6. Plot the image of the line segment shown after the translation of 4 units to the right. So here's the image, goes to the right. There you go. You could even count it. 1, 2, 3, 4. 1, 2, 3, 4. How about this one? 2 units left. Good. 1, 2. 1, 2. 2 units left. There you go. What about this one? 3 units up. Let's see if that works. 1, 2, 3. 1, 2, 3. Good. Do you see how I just carry each point? Next one, 1 unit down. Looks like that. Let's see. That's 1. That's 1. Okay. That is as simple as it gets for part 6. Okay. Let's go to point 7. The coordinate plane shows the figure ABC has been transformed to form figure A prime, B prime, C prime, and D prime. Explain how the figure was transformed. Include all necessary works in your transformation. Please understand it starts from here, the small trapezoid of A, B, C, D, into the bigger trapezoid of A prime, B prime, C prime, and D prime. So let's take a look. The first thing that happens is it went up, then it went to the right. The reason why is because I want to match up this vertex. Okay? So let's take a look. So it went 1 unit up and 1 unit to the right. That's the translation. I just want to do that so D and D prime matches up. Now, watch it. It got bigger, okay? So there's a dilate with a scale factor 2. Some of you are wondering, how did I get the scale factor of 2? Watch this, okay? Look at the length here. 1, 2. You see the top length is 2? What's the top length here? 1, 2, 3, 4. How do you go from 2 to 4? You multiply by what? 2, right? You multiply by 2. That is the reason why, that is the reason why they say here, you dilate with a scale factor of 2. So here, for this image, please understand that the transformation had multiple transformations. One, it had a translation from D to D prime, then it dilated to get bigger by a scale factor of 2. Look, you have to include the scale factor if you ever talk about the dilation, okay? Here, I just wrote it in common English about the translation, but if you want to write this in the general rule, it would look something like this. 1 unit right, so it's x plus 1, and y is 1 unit up. So y plus 1. Close the parentheses. Okay, that's how that one would look like. Okay, that is part 7. Okay. We have one more, which is part 8. So you're going to determine if the statement in the triangle below are true or false about the sequence of transformation that can verify that rectangle ABCD is congruent to rectangle A prime, B prime, C prime, and D prime. Okay, so number 1, rectangle ABCD is translated 2 units down and 4 to the right. Okay, let's take a look. It goes down 1, 2, then goes to the right. How many? 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, it looks like it matches up. So we would say it's true. The translation does not change the object size or shape, therefore it is congruent. So during the translation, the object does remain the same. So yes, this is true, and it does show that it is congruent. 2. ABCD is reflected over the x-axis. Okay, here's the x-axis right here. This is the line of reflection. Then it goes 7 units to the right. So it reflects, so it should look like this. When it reflects, then it moves I try to do it best as I can. Then it goes 7 times. It's 1, 2, 3, 4, 5, 6, 7. So looks right. It matches right on top of each other. Okay, so we'll say it's true. Because the reflection and the translation, because again this is a reflection and a translation, does not change the object's shape or size, therefore the two objects are congruent. Okay, shows how it maps right on top of each other, therefore it's congruent. Ooh, let's look at 3. I want to make sure that you understand that what is ever in red needs to be changed on your review sheet. I think this was different. Okay, I think I wrote reflect over the y-axis, then like 3 units to the right, which is wrong. Okay, make sure you write this as the correct fix. So, can rectangle ABCD reflected over the y, so reflected over the y, then reflected over the x. So this is how it this is how it looks like once you reflect it over the this is what it looks like once you reflect it over, okay, the um, y-axis, then you reflect it over the x afterwards. So here you would say this is true because the two reflections right here reflected over the y, then reflected over x. Change does not change the object's shape or size, therefore the two objects remain congruent. 4. Rectangle ABCD is rotated 90 degrees clockwise about the origin, then translated 2 units to the right to make A prime, B prime, C prime, and D prime. Watch the rotation, okay? And you see it rotates right here 90 degrees, and you see how it turns it. Even if you translate it 2 units to the right, it doesn't do anything. So we would say false. The translation does not get the original object to map on top of the second one. Although the translation doesn't change the shape or the size, it doesn't show congruency because it does not map right on top of each other. So it's right here on the side. It is not right on top of this one. Okay. So this, right, is not right on top of this. That is the reason why you cannot call it congruent. Number 5, if rectangle ABCD is rotated 90 degrees counterclockwise above the origin, then translated 2 units down to make A prime, B prime, C prime, and D prime. So this is what it looks like when you rotate it 90 okay, counter clock, okay. This is when you go counterclockwise, right? So when you go 90 counterclockwise above the origin and translate 2 units to the right, do you see how that new red parallelogram is not right on top of the image that we want? So we would say this is false, okay? Because the transformation doesn't get the original one to map right on top of the second one. The fact that it cannot map right on top of each other, we cannot say it's congruent, okay? It's only congruent if we could show it matches right on top of each other, okay, like what we did for 1, 2, and 3. Those transformations mapped right on top of the new one. Okay, 4 and 5 are false because they do not show us that mapping. Okay, so there you go. Those are your solutions for 5, 6, 7, 8.